All right. Now let's see. Yeah. Can you hear me? Can you hear me? Yeah. All right. I'm sorry. I'm broadcasting from my remote location, which happens to be in my study room in the basement. Not in the studio today. I'm on isolation, going through the COVID protocols right now, so I didn't want to come out and infect anyone. So I'm staying in isolation today and the next 3, 4, 5 days till I make sure that I'm testing good. But welcome to the BFTAA and More show. This is your host, Louis George Walker, and I am so glad to be with you today. Yes, yes, yes. We've got great things going on, and I'm doing all right. I'm feeling okay and everything, but me and my wife have both had to go through this, and it's okay. It's okay. But this is KUAW Radio. KUAW stands for Knowledge, Understanding, and a Wisdom. That's right. So we're here from the W.E.B. Du Bois Learning Center and the Black Family Technology Awareness Association that came together to form this station, and we're here to bring you right now some news and information that's going on the technology front and some of the things going on in the community. This is BFTAA and More, and we're just glad to be with you today. So, one of the things that we do all the time here is we go into what's going on. We're into that research and development, or at least reading about it. We haven't did as much of it, but we're doing some with our young people that we have out and about working with us. And we're supposed to have some more even this week that's really going to be great. But we'd like to go into what's going on at NASA, the National Aeronautics and Space Administration, so that we can learn a little bit of what's going on. We're also going to talk a little bit about quantum computing, which I don't know a whole lot about, but it's interesting. I'm learning because our new computers, not anytime real soon and stuff, but at some point pretty soon, quantum computing is going to be the type of computing that we're going to be doing. We're going to be able to use it in everything that we do with computers now and just allow us to do even more. It's just like with AI that's coming along. It's not that it is going to take away anything. It's just going to allow us to do even more of something. So we're going to do a little bit of studying on that, but I'm going to bring a little bit more of that to you and all as we keep going. But we want to learn. This show is about learning, about education, about working to improve our standard of living. And by using technology, we can improve our standard of living. So we want the young people to get involved in STEM, which is science, technology, engineering, and math. And we're going to talk to you a little bit about how you can help our STEM program right here in Kansas City, because we need your help to keep things rolling. So we're going to talk to you a little bit about that also. But we're glad that you're here. And before we go too far down the road, we want to see a little bit of what's going on this week at NASA. So stay tuned, hold on, here we go. I think. Wait a minute. Okay, I tell you, work on a different computer and things just don't seem to happen the way they did on the other computer. But that's okay. I probably got this too far in the background behind my image. So we'll take it to the top. Now let's see what's going on this week at NASA. There it is.
Making the grade for investing in small business. A few of the stories to tell you about this week at NASA. A Rocket Lab Electron rocket launched from New Zealand on July 18th to carry 4 small satellites to low Earth orbit for our Starlink mission. The cereal box-sized spacecraft will work together as a swarm to see if they can maneuver, communicate, and make decisions on their own without real-time updates from ground controllers. The mission could help to advance self-coordinating robotic swarms for future science and exploration missions to the Moon, Mars, and deep space. Our storm-observing tropics satellites recently collected the mission's first views of hurricanes. Late last month, the mission captured imagery data of the first named storms of the Eastern Pacific hurricane season. Tropics uses a constellation of 4 identical small satellites to observe tropical cyclones about once an hour, far more frequently than most science satellites. The It could hand officials better understand and prepare for rapidly evolving storms. During a July 18th event at NASA headquarters, the Small Business Administration announced that NASA earned an A on the fiscal year 2022 Small Business Federal Procurement Scorecard. The scorecard looks at how federal agencies rank on meeting their small business goals. NASA has directly invested $3.6 billion in over 1,700 small businesses across the country, creating good-paying jobs and opportunities for Americans in all 50 states. According to new research from NASA and Japan's Osaka University, rogue planets, which are planets that drift freely through space untethered to a star, far outnumber planets that orbit stars. With so many rogue planets out there, researchers believe that our Nancy Grace Roman Space Telescope could find about 400 rogue planets similar in mass to Earth after the telescope launches in 2027. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
There we go. Let's see what we got echoing here. All right. Man, I tell you, working from this location now, I shouldn't have a problem. Turn this down. All right. Okay. Don't know exactly what's going on, but we'll keep on pushing through and stuff. So we're wanting to get kids involved in our robotics program. If you'd like to get a young person that you know or someone in your family or a neighbor kid involved in our competitive robotics, we're working with kids from 9 to 18 years old. Just contact us at our website, www.bftaa.org, www.bftaa.org, or you can email us at bftaa@sbcglobal.net. You can also find us on Facebook at the Black Family Technology Awareness Association. Another thing is that we're going to be looking for volunteers to help us in delivering our programs to the young people, and we want to keep you in mind for doing something like that. So let's get together. Now we're going to go back. We're going to see what's going on in the space station. So let's go and see what's happening at Space to Ground.
Welcome to Space to Ground. I'm Shaniqua Vereen. This week, NASA celebrates a milestone in space, new technology comes on board, and we have a new crew setting their eyes on the space station. On Tuesday, July 18th, NASA astronaut Frank Rubio celebrated his 300th day in space. Rubio has officially become one of only 4 American astronauts to surpass 300 days in space on a single mission. He will return to Earth aboard a Russian Soyuz spacecraft no earlier than September 27th, meaning he will have logged a total of at least 371 days in orbit. That tour of duty will beat the previous record of 355 days set by U.S. astronaut Mark Vande Hei in 2022. New technology on the ground and in space help astronauts to do their jobs more efficiently. This week, NASA astronauts Frank Rubio and Woody Hoburg conducted the Surface Avatar experiment and helped deploy small satellites called CubeSats. In the Surface Avatar experiment, the ISS crew commanded a team of robots in a simulated extraterrestrial surface habitat on Earth, located at the German Aerospace Center near Munich. This technology demonstration seeks to understand how astronauts can command robotic assets on a planetary surface with maximum efficiency and with the least amount of fatigue. The task's responsibility is shared between the astronaut in orbit and the robots on the surface. Ground teams deployed a pair of CubeSats developed by graduate students from the University of the Philippines, Diliman, in collaboration with the Kyushu Institute of Technology. The Maya 5 and Maya 6 CubeSats will image the Earth's surface, collect data from ground sensors, and be used as an antenna. The Cross-Border University project creates a path for making space education more accessible and inclusive in participating countries. And that's Space to Ground for now. Thank you for watching. We invite you to tune in on Tuesday, July 25th for a pair of conferences to highlight the upcoming crew rotations. The briefings will cover NASA's SpaceX Crew 7 mission to the space station, and NASA astronaut Laura O'Hara, who will launch on September 15th on a Soyuz spacecraft, will also participate in the briefings. You won't want to miss it.
All right, that was Space to Ground, and we're going to continue working with you. I'm playing around with my microphone here, trying to see if I can get it right, but that's something we'll work on while we're in our remote location. Since I'll be here another couple of days, I'll get some time to practice and make sure that we can get it right. Oh, man, I tell you, it's been a great couple of weeks. July has been a busy month. We've been doing a lot of different things. We did take a vacation or a trip with my wife and a granddaughter, and we went to the Grand Canyon and went to a family reunion picnic out in California. So we had a great time, got to visit with friends, relatives, my brother. So it was really good, and I advise everybody to take a little time and get away sometime. Take a little time and take a trip, travel, see some of the sights in this great country and in other countries around the world. But don't be limited to just right here in Kansas City. If you can, if you're able, it'd be good to get out and see some other things around the world. That's right. Well, hey, one of the things I did want to talk to you about is getting volunteers. You know, ladies and gentlemen, you know, we want to welcome you to our radio show, and we bring you the latest news, exciting opportunities in the world of education and beyond. But today, we have a fantastic opportunity for all you passionate educators out there who love to work with young minds and inspire the next generation of innovators. So you don't have to be a licensed teacher or anything like that. All we need is somebody that's interested. You know, we're looking for a coach to lead a talented team of 9 to 12-year-old students in the thrilling world of competitive robotics in the Lego League. Yes, that's right, folks. If you've got a knack for creativity, problem solving, and fostering the love of STEM education, this is a chance that you've been waiting for. The 2023-2024 Lego Challenge is just around the corner, and we need some enthusiastic, dedicated coaches to guide our bright young minds on their journey. The Lego League is an incredible program that not only allows students to have fun building amazing Lego creations, but also teaches them invaluable life skills like teamwork, critical thinking, and communication. It's an experience that they will carry with them for a lifetime. So whether you're an experienced coach or someone looking to make a difference in the lives of young talents, we welcome you to be a part of this wonderful journey. To find out more and to get involved, visit the Black Family Technology Awareness website. It is www.bftaa.org. That's www.bftaa.org. And if you prefer reaching out through email, you can contact us at bftaa@sbcglobal.net. That's bftaa@sbcglobal.net. And for those who love the personal touch, don't hesitate to call me, George Walker. Yes, the friendly representative here. You can give me a call at 816-805-0406. That's 816-805-0406. So what are you waiting for? Be a part of the Lego League magic and inspire young minds to reach for the stars. Join us today as a Lego League coach, and together let's nurture a new generation of innovative thinkers and problem solvers. Remember, you can contact us at our website, www.bftaa.org, by email at bftaa@sbcglobal.net, or you can speak directly with me, George Walker, at 816-805-0406. Thank you for tuning in to KUAW Radio. Let's make a difference in these young students' lives and build a brighter future together. Stay tuned for more exciting news and updates right here at KUAW Radio, Kansas City's global community radio station. All right, I want to thank you for sitting with me through that commercial, and I hope you enjoyed the broadcaster or the announcer on that. Yeah, but we're glad to be here and just glad that you're able to learn and see some of the things that we're doing. We want to get kids involved in science, in technology, so that they can be better at things at school and stuff. It's a lifelong learning opportunity. And we want our young people to get in there and learn and be with the best of them as they go forward in life. You know, there's no telling how far they can go once they get started. So we have to work with our young people to make sure that they get started in learning about science, technology, engineering, and math. That is STEM. Also want to let you know that they're enrolling or getting ready to enroll at the W.E.B. Du Bois Learning Center. Yes, the W.E.B. Du Bois Learning Center. If I was down at the studio right now, I had a photo. I'll have to look on my computer to see if I can find it. I don't think I'm going to be able to find it while the show is going on. But the W.E.B. Du Bois Learning Center, going on 50 years of providing technology and tutoring help in Kansas City for adults, for young people, for the community. Well, that's enrollment is starting. If you want to get your young person involved in a tutoring program, be sure and contact the W.E.B. Du Bois Learning Center. We're located at 4510 East Linwood Boulevard in Kansas City, Missouri. We hope that you would join in and reach out to the organization, help make a difference in what we're doing here. Yes, we want to thank you for that. Now, another thing that we've been looking at, and I talked a little bit about it, I think that was last week. Yeah, that was after I'd been back, was quantum computing. Now, quantum computing, as we have learned or as we had saw, is pretty interesting because if you come through the normal way of doing computing that you know most of us learn, is that there's two states that your computer looks at with a bit, and bits are the whole brains or the whole information path of, not path, but they carry the information of the computer as a bit. There's thousands of bits, as you see, there's millions of bits, there's trillions of bits on your computer when they talk about megabits and terabits of storage or memory. Each bit carries a bit of memory, but it only has two states that it can work in, and that is O and 1. So O and 1 is its two states to work in, and now that we've got quantum computing, we can go past that. Let's see. Let me see. I was going to try and pull up some information I had on it that comes from Google. Let's see if I can find that. because Google is one company that you really don't think about as being big in computing, but they are. They're into this quantum computing, really trying to move the thing forward. So let's see, I was trying to find an educational site on this, if I could, so that you can see a little bit about it and hear a little bit about the research and what's going on with quantum computing. So we will see if we can get there sooner or later. This may be it. This may be the place I want to get to. This is it. All right. Now, I don't know if you'll be able to see this or not, but for those of you that are a little bit geeky out there, we're not going to listen to the whole video, but we'll spend about 6 or 7 minutes so that you can start getting an idea about quantum computing. That's what I think is the future. Well, I don't just think it, I'm pretty sure that is the future of computing. We went a long ways with the O's and ones, but we need to take it a little bit further and do things a little bit faster. So let's see if we can bring that up to you right now. Try and get this to you. And let's see. Okay, here we go. Let's take a little bit of educational trip into quantum computing. Here we go. Get your pencils and paper ready. Get yourself ready to learn, because this is interesting stuff, but it is kind of a different level. Here we go. Quantum computing.
Quantum computing. It's been all over the news lately, often accompanied by an air of mystique or an assortment of fantastic promises. But what does quantum mean in the context of computer hardware? What distinguishes a quantum computer from a regular one? What does a quantum computer look like? How do we build it? My name is Marissa Justina, and I'm a research scientist in the Google AI Quantum Hardware Lab. I'd like to unpack those questions, and hopefully, in about 5 minutes, the term quantum computer will have just a little more meaning for you. We're working to build devices that we can interact with, that is, devices we can control and read out, which behave reliably according to a simple quantum model. In other words, we're building quantum computing hardware. Quantum hardware can be used as a tool for approaching certain kinds of computational problems. So our ongoing efforts are both to develop the hardware and to develop algorithms that leverage this hardware. Let's start with the first question. What does it mean for hardware to be quantum? For that, we'll talk for a moment about quantum mechanics. A model is the physicist's tool to make predictions about what will happen when we put the universe into a certain configuration and poke it in a certain way. For example, if you'd never built a skyscraper before, you might make a Lego version before building at full scale. That's a model. Models can also be expressed in the language of mathematics. The most fundamental model of nature we know was developed in the early 20th century and is known as quantum mechanics. The word mechanics refers to the mechanisms by which things happen. The word quantum refers to discrete quantities of energy or some other physical quantity. Within quantum mechanics, energy comes in packets, sometimes called photons, and you cannot have fractional packets. So, what's a quantum object? People sometimes think of a quantum object as being tiny, and a quantum leap as being large. However, the word quantum doesn't dictate an object's size. Actually, a quantum object is one that relates in a well-defined way to a single quantum of energy. For instance, the photon I mentioned before is a quantum object. A photon is a single particle of energy. Similarly, atoms are quantum objects. An electron flying around an atomic nucleus may be excited into a higher orbit only by a particular quantum of energy. There's no halfway point between the lower orbit and the upper orbit. If the wrong energy is provided, there simply isn't a corresponding orbit for the electron to land in. In a nutshell, a quantum object is one whose observable behavior reflects that nature only offers energy in discrete packets. Now, on to the next question. What differentiates quantum computing hardware from a regular computer? In essence, Quantum hardware lives in a richer world than its conventional counterpart. Let's consider a simple, abstract quantum object, which is entirely described by the fact that it can be in one of two different energy levels. Let's call those levels 0 and 1. You can interpret those brackets around the 0 to mean this is a quantum energy level called 0, and likewise for the 1. Here, for example, is a quantum energy state named psi. Recall the classical bit of information, a switch that can take one of two values, 0 and 1. Because of the apparent similarity between our quantum object and that classical bit of information, we call this quantum analog a quantum bit or qubit. One peculiar feature about quantum mechanics is the existence of superpositions. A superposition is like a special mixture of the energy levels 0 and 1, where the weight of each energy level is given by complex constants C0 and C1. If we measure the energy of our qubit, we will sometimes observe 0 and sometimes 1, where the value of sometimes is given by the constants. An individual measurement will yield an outcome of 0 or 1. There are no other options. But before the measurement occurs, we know at most the chances of getting a 0 or a 1. We can't know the actual outcome for sure until we measure it. Therefore, when we want to talk about the energy state of the qubit before we've made the measurement, we use this superposition to represent that the qubit hasn't decided yet which outcome to display, even though the chances of getting each outcome are fixed. Now, even admitting that this superposition business is a little unusual, we can accept that it's easy enough to represent one qubit. We just wrote it down right there. Thinking about more qubits gets increasingly difficult. Suppose we add a second qubit. If these were conventional switches, we could think about each switch independently, but qubits are different. Just as one qubit can be in a superposition state, two qubits can share a superposition state, where, for instance, the measurement outcome is unknown but will certainly be the same for both objects, or opposite for both objects. For example, here's a state where a blue qubit and a yellow qubit are together in a superposition state. Here, they're correlated to each other. Before the measurement, it cannot be known whether the blue qubit will turn up 0 or 1. But a measurement of both qubits will certainly always give the same answer for each. Similarly, in this case, measuring the blue and yellow qubits will always give opposite outcomes. This means that in order to fully describe two qubits, we need to consider Cs for all possible measurement outcomes we could see. To describe 3 qubits, we need 8 Cs. Describing 4 qubits takes 16 Cs, and so on. Each time we add another qubit, it takes twice as much information to describe the whole pile of them. That is the crux of what differentiates quantum hardware. The quantum system lives in a richer space, so that representing n qubits with a classical computer requires 2 to the n numbers. But does this mean that a quantum memory with 100 qubits corresponds to a conventional memory with 2 to the 100 bits? Not so fast. Quantum hardware is very effective at encoding and processing certain kinds of information, but it cannot efficiently mimic many useful aspects of its classical counterpart. When we say that a picture is worth 1,000 words, we don't abolish words entirely in favor of pictures. Adding quantum hardware to our modern computing capabilities would be like adding pictures to a communication strategy that up to now used only words. So what does quantum hardware do well? The exponentially growing complexity of quantum systems also gives a clue about where quantum hardware could be useful. In the fields of chemistry and materials development, simulation of molecules could be a powerful technique to learn about the properties of a new molecule.
Enough of learning about that right now, but you see how interesting that is for some of us. Now, for some of us, it was like, whoa, what are we talking about? But to get away from the state, and those of you that learn binary numbering systems know that there was O's and ones, and that gave you the binary numbers that you wanted. You'd have O1, 1O, whatever. In this quantum, you have the same numbering system, but it's just carried a little further per bit. So with those qubits, it just really seems like they're doing a lot more of computing in that space. And as she says, it's not going to get rid of the binary language, but there's certain things that with a quantum computer, you would be able to do better. So that is one thing that you want to make sure that we start getting our young people in on IT, computer design, quantum physics, you've got a kid that's good in math, good in science, then we need to encourage that and take them as high as they possibly can go with it. Because that is where the future is, not just for your family or my family or your child, but for us as a country and for us as a people. That's where the future is, for humankind. So we've got to get in there and embrace this technology and learning about these things. Some people would say, well, you can't learn too much or you get into this and that. But basically, we've got to keep growing and learning. We've got to keep exploring and keep moving the ball a little bit further. That's what mankind has always done. We're moving faster now than we used to move, but that's not a problem. I mean, that's not the end of the world. It is a change, though. There's a lot of things changing right now, and sometimes in the changing, there's people and there's things that are going to be left aside or going to be not used anymore, but there'll be new things coming along, and we've got to be ready for those new things coming along. I used to work in a job where I was good with reading a voltmeter and tracing a circuit from point A to point B that was a straight line or went through a couple of switches or what have you. But when you came to computing, it was altogether different. We went to a thing, time division multiplex, and then they went to Ethernet and a whole lot of other ATM type of ways of transmitting data. And it was no longer just a straight line from point A to point B. So now the thing I found is that I could either stay with what I knew and work on that, and probably could have stayed there a few years longer, maybe even retired from my job at that, although I doubt it. But I could also try and learn what this new thing is and go even further. I chose to try and learn the new. And did I become a rocket scientist, a computer scientist? No. But I know more about computers than I did when I first started. I know more about digital transmission than I did when I first started, because I was working in an analog world. Now I'm working into the digital world. And as I've been learning about this quantum thing, they start mentioning the wavelengths, it works sort of like a wave. And it just started coming into my mind that, okay, we're starting to get something that maybe gets us back to a hybrid of the digital and the analog working together. So that's going to be interesting. But, it's good to learn. It's good to research and always keep digging. So tell your kids, and even you as an adult, if you're grown, if you're listening to this, don't stop learning. We can't stop learning. Life is a forever learning process. It is nonstop education. We're learning one thing or another. Find something that you like and learn about it. It may not be about computers or science and stuff. You may like gardening and planting flowers. Learn all that you can about that. Continue to exercise your mind. Consider to use your brain. Consistently do these things so that we can stay up on what's going on. But I thank you for joining. I hope that you learned a little bit with the supercomputing and also with the space to ground, because it's something to see those satellites that they're sending up. And if you notice, there was a lot of robotics and programming that was going on in what NASA was doing today, and what they were showing you is how astronauts will work with robots on the planet and how to do it more efficiently. But they're working with robots. So that's what our program is. We're getting kids involved in robotics. That has some programming, that has some mechanics into it. It has some physical work. But that is something that our kids need to be learning, is how robotics work. The satellites that they're saying are going to work as a swarm. Well, there's robots that they're using now, and some of our drones that are actually going up and working as swarms when they give you those displays. If you've ever seen a drone light show, it's amazing. It's fantastic. I know some cities tried to use those instead of fireworks this year, but we were at a baseball game and they had the drones fly and the shapes and figures that they can make with their lights and the colors. But all of that takes us learning and knowing new things. So don't give up learning. Don't give up digging and trying to do a little bit more and a little bit better. It helps us all. It helps us in life. God wants us to learn. He gave us a brain so that we can use it, so that we can learn more, so that we can do better. So let's do that. Let's use the tools, the talents that God has given us to make things better for everybody. I want to thank you for listening to the BFTAA and More show. As I say, I'm broadcasting from my remote location due to having to be on isolation for a few days. I will be back in the studio next week. If the good Lord's willing, I'll be back in the studio. We'll be able to broadcast live from there, and we're going to continue to learn and to grow. Also, want to remind you that we need volunteers. The Black Family Technology Awareness Association does not discriminate. We'll take all of you. We don't discriminate because of age, race, sexual identity, none of that. We need people that are interested in helping our young people learn about technology. So if you want to do that, if you're interested, if you would love to help us help the young people in Kansas City, get in touch with the Black Family Technology Awareness Association. We're looking for somebody to help us with our Legos. So if you know somebody that does Lego robotics, if they're into it, if they just build things with Legos, bring them down. We need to see you. We meet on Saturdays from 12 to 2. That'll be going, or it's either 12 to 2 or 12:30 to 2:30. I don't know exactly what this year's program is going to be, but we're down there every Saturday. And if you come around 12:30, you'll catch us there. But come to the W.E.B. Du Bois Learning Center. You don't even have to volunteer. Just come and look and see what we're doing, what's going on there, and maybe you might want to get involved. Maybe you will not. Maybe you'd just like to support us, and we can use your financial support just as well as your physical support. So come down to the W.E.B. Du Bois Learning Center, 4510 East Linwood Boulevard. I'll be there Saturday morning. I'll be there by noon and willing to talk to anybody, show you around, let you see what we're working on, what we're trying to do. So if you want to get involved with us, please, 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 please contact us right here. You can also call me, 816-805-0406. That's 816-805-0406. There's so many opportunities out here for our young people. People are coming to me, and companies have things to do, but we need the people to work with the young people also. So we need volunteers like you to come and help us to work with the kids. Each one of us can only do so much, but together we can do so much more. So, excuse me. So we need to come together and work together to do more in our community. So come on down Saturday and check us out. I'm George Walker. I'm president of the Black Family Technology Awareness Association. I'll be glad to meet you, to see you, to talk with you. And, you know, we can just shoot the breeze, or we can show you what we're doing, and you might really want to become a part of what the Black Family Technology Awareness Association is doing in Kansas City, Missouri. So thank you for listening. Thank you for tuning in. We'll be back again next week. We're on from 5 to about 5:40, 5:45, sometimes 5:50. But we get out of here before 6 o'clock because I have another show starting in. You can also, I didn't even mention this earlier, you can listen to KUAW Radio. The past shows of mine are archived on YouTube and Facebook. So if you go to KUAW-radio on Facebook or KUAW Space Radio on YouTube, you can see all of our shows and the other shows that come on here. Like and share and subscribe to the KUAW radio page. That way, anytime we go live, you will get a notification that there's a live show going on. We have shows going on different times throughout the week and on the weekend. So come and listen to us. Also, you can pick us up on the audio side. We broadcast 24 hours a day. We play music. We have talk shows. We have a lot of information that goes out on the radio every day. So you can listen to us live. If you have a smart speaker, a Google speaker, or one of those, tell it to play KUAW and we'll come through. You can also pick us up on the Get Me Radio app, on the TuneIn app, on My Radio Tuner, and on the online radio box and Radio Garden. So all of those sites, you can pick up KUAW Radio broadcasting from Kansas City, Missouri, 24 hours, the internet's powerhouse station. Yeah, that's us. You can listen to some old school music, Professor Smooth jazz, some gospel. We've got the blues. We've got everything that you want to hear right here at KUAW Radio. So thank you for tuning in today. But be sure to tell a friend about us and write us, send us a note. You can contact KUAW at KUAW985@gmail.com or go to KUAW Radio on Facebook and YouTube and pick us up there. We'd love to hear from you. We're on Facebook, YouTube, we're on Twitter, we're on Instagram. So we have a lot of ways that you can get in touch with us. So hit us up. Let us know what you think about the station and what we're doing. Maybe you want to be a part of the radio station, that you'd like to come in and see about hosting a show or learning how to work this computer system to get these broadcasts out. So if you want to do that, if you want to work with the radio station, we'll be glad to have you. So get in touch with us. KUAW Radio, Kansas City's global community radio station. I am your host, Louis George Walker, and I am so glad that you joined me today. Be sure to tune in next week for the BFTAA and More show, and continue listening to KUAW Radio. Lock it in so that you can hear us day and night. KUAW, knowledge, understanding, and wisdom right here in Kansas City, Missouri. Thank you, and have a great day. Now I got to see about getting out of here. And it's kind of interesting when you're working it yourself. All right. We'll see you. Have a great one.